Problem 5-89. Graph the two functions at right on the same set of axes. How do the two graphs compare? Then letter B, suppose the first equation is y equals k times m to the power of x, and the graph is shifted up b units. What is the new equation? So once again, this goes back to when we were transforming our parent functions. If we think about, we have y equals a times b to the power of x minus h, and then we're going to say plus k. Remember, each of the parameters, our a, our h, and our k, all affect the shape of our exponential curve. So what we're looking at here is, if we compare it to the equation we've got, y equals 3 times b to the, sorry, not b, this would be 2. Got all excited there, forgot what I was doing. We have 3 times 2 to the power of x. Okay, well, a is our 3, b is our multiplier 2, and it's just being raised to the power of x here. So we're not translating it left or right at all. And this is the same thing as saying like plus 0. So what we have here, when we graph it, it should be an exponential curve that's going upward, and we should have a horizontal asymptote where our y value equals 0, because remember, our k affects our horizontal asymptote. Now, if we do the second one here, we've got y equals 3 times 2 to the power of x plus 10. Well, if we increase this value of k plus 10, remember that translates our exponential curve up 10 units. So it's still going to be an exponential curve, but our horizontal asymptote is going to go from being at 0. Let me catch up to myself here. Our horizontal asymptote is going to go from being at 0, and it's going to move up 10 units, and it should be where y equals 10. So how do the two graphs compare? They should be very similar graphs, except for one is 10 units higher than the other. Let's check that on the graphing calculator now. So I've got my calculator out, and I'm going to go ahead and graph the first one, which is 3 times 2 to the power of x. Oops, let's delete that. So we'll graph that first one just so we can see what it looks like. Comes up here, goes up. Now, with the next one, if I'm guessing that it's going to raise it up 10 units, I'm going to go ahead and adjust my window. I'm going to increase my y max so that I can see if I'm correct. I'm going to make my y max 20. Let's go in here. Let's type in the same function, but then let's add 10 to it. And graph. So this is our original one again. You'll see it's the exact same shape there that it was. Our asymptote there, where y equals 0. And now you see the second one here. As it comes across here, we have our horizontal asymptote where our y equals 10. So we've pretty much just shifted our exponential curve up 10 units, or translated it up. So let's pull that out there so we still have it. Oops. Now there's a little undo thing here somewhere. All right. Let's move this guy over here. So we've just translated it up 10 units. Remember, that is the effect of k. So letter B says, suppose the first equation is y equals k times m to the power of x. So this is like our first equation up here. And the graph is shifted up b units. What is the new equation? Well, remember, b is like our k. B is like, I should say it's this b. B is like our k. So that means it's going to go up b units. So our new equation should end up being y equals k times m to the power of x plus b. Okay, because it's going to shift it up b number of units. There's our answer for part B. Part A, it's going to shift it up 10 units. This is problem 5-89. Hopefully this helped you out. If you have questions, please make sure you reach out to your teacher. Thanks for listening. Have a good night.